Hello everyone, last video on geometric design on multi-lane roundabouts. We discussed how you can control the side to the left, this angle here, so drivers can turn their heads to the left comfortably, without having to look out their shoulders to see the oncoming traffic from the left. Now, following the subject, this video covers how you can measure the entry angle. Alright, we're still at the second part, geometric design, introducing geometric elements, and you know the references, nothing new, so no introducing. Let's just skip them and get started. Alright, first notice that the entry angle is not a controlling design parameter. You see, of course, according to our references and standards, Wisconsin DOT calls it a gauge of ease of entry to the right and side to the left. Actually, it helps us to get a better alignment for entries to improve both safety and capacity of roundabouts. Let's first demonstrate how we can measure it, and then we will discuss it. Depends on the distance between the left side of the entry of interest and the left side of the immediate exit. On the right, distance between A and B. There are two different methods to measure entry angle. If the distance between A and B is less than around 100 feet, then the exiting traffic governs the method for measuring entry angle. In this case, all you need to do is to draw the center line of the entry, then extend it till it intersects with the inscribed circle. Now, from this point here, you draw a line tangential to the center line of entry. You do the same for the exit. Draw the center line of the exit. Now extend it till it intersects with the inscribed circle, and again a line tangential to the center line of exit. Now this angle here, or this one, is twice the entry angle. Alright, now that we know how to measure it, let's see how it affects the actually capacity and safety of the roundabout. To do this, I've got two figures here to be compared with each other. We got the same inscribed circle diameters, the same geometry for exits, but the different alignments for entries. This one here, this angle is 25 degrees divided by 2, it's around 12 degrees. So the entry angle for this alignment is 12 degrees, and we got 41 degrees here divided by 2, it's around 20 degrees, almost twice the entry angle for this alignment. This one here represents an alignment with small entry angle compared to this one with a greater entry angle. You see, it's easy to notice that making a right turn from this entry at this alignment due to the small amount for entry angle is really easier than this one here. So smaller entry angles, that means easier making a right turn from that entry. Well, it's also obvious that we got more deflection for entering traffic at this alignment compared to this one here, and more deflection at entry. That means more speed control of entering traffic, which is desirable. But there is an issue. You see, if this angle gets too acute, then the entering and circulating traffic will go through a kind of merging maneuver. Instead here, due to the greater angle here, it's more of a crossing maneuver, which is more safer, which is safer and which is more desirable. You see, there is also another issue due to the small angle here, which is if there is a vehicle at this position, it will be kind of difficult for entering traffic to recognize if this driver gonna leave the roundabout or it gonna go on circling the Sonora Island. But due to the greater angle here, it will be easier for entering traffic to recognize, for example, this driver gonna leave the roundabout. To make it more clear, let's have a look at this figure here. Due to the proper entry angle for this entry, it's obvious that entering traffic can easily recognize that this driver gonna leave the roundabout, so they have to yield to this driver and give priority to this driver. To avoid these issues, there is a recommended range for entry angle. Wisconsin DOT recommends a range of 20 degrees up to 30 degrees. And it also actually mentioned that the roundabouts with entry angles more than 16 degrees also have acceptable performance. So you may want to consider 16 degrees as a minimum for entry angles of multi-lane roundabouts. But now what if the distance between the left side of the entry and the left side of the immediate exit is more than 100 feet? In this case, the circulating traffic will govern the method for measuring entry angle. You see, suppose we don't have this leg here, and so the distance between A and B in this case normally will be more than between A and B normally will be more than 100 feet. In this case, first you draw the center line of the entry, same procedure we did a couple of minutes ago, and then from the point that intersects with the inscribed circle, you draw a line tangential to the center line of the entry. Now, from where it intersects with the center line of the circulated roadway, you draw the line tangential to the center line of the circulated roadway. But the problem is that if you recall from some video before, we normally put a tangent portion advance of the yield line to put drivers at entrance directly in the right position towards the right lane within the circulated roadway to avoid pass over lag. And if we do this, this line will be parallel to this line, so there will be no angle in between to be measured as entry angle. This is where it gets confusing when it comes to measuring entry angle for these cases for multi-lane roundabouts. I have no idea we can measure this angle or what's the method for, and as far as I know, to my knowledge, no standard references mentioned this. And if you have any idea how we can measure the entry angle for these cases, I would appreciate if you share it with us. Maybe just because there is no exiting traffic, maybe it's not important to be checked, but I'm not sure about it. Alright, it was all about the entry angle, how to measure it and how it affects the capacity and safety of roundabouts and what's the recommended range for. Hoping it was helpful, and thanking you for giving me part of your daytime and watching the video. I say goodbye for now.